Alright, what's good, y'all? It is day 22. I don't remember what my... I don't remember. I always forget the day. I should always check before I... Yeah, day 22, that was yesterday. So day 23. I didn't get to work on the... Did I finish packages? Oh yeah, I stopped it because it's
I'm going to quickly walk you through, from a high level, the structure of a production-ready Go module.
Oh, I didn't get to finish it. Okay. Let's try to get through it and then try to... I want to start concurrencies really soon, so... Because the rest of the stuff was just reading material. Like, I wasn't able to fix... Yeah. Oh, yeah, the Go and stuff. Oh, yeah, this thing. I don't know why this wouldn't work. I haven't had time to fix this up, but I'll take a look at that in a bit. Custom package. I shouldn't need to understand this, so let's write a package to import. Create a sibling directory. Go mod it. Remote server, so it's like github.com or GitLab. Boatnoah, and the name of the directory. In the directory, paste the following code. Notice only capital names are exported, meaning they can be accessed in other packages. Uncapital names are private. Notice that main.go or main in the package. There's no main. So go build, this isn't, because this isn't a main package, it won't build an executable. However, go build will still compile the package and save it to our local build cache. It's for checking for compile errors. Run and submit, yep. So, I see how it's kind of being structured. And I definitely want to see this. Yeah, I wouldn't be able to use this, unfortunately. The replace keyword like we did in the last assignment is not advised because it can be useful to get up and running quickly. The proper way to create and depend on a module is to publish them to a remote.
I'm going to quickly walk you through, from a high level, the structure of a production-ready Go module that's intended to be used by kind of third-party applications. So this is a module that I've published as a library to GitHub for other Go applications to download and use in their code. So this is the github.com/wagslane/go-rabbitmq GitHub repository. So this is a GitHub repository that I maintain. It's just a little package for RabbitMQ users, a little Go client for RabbitMQ. So this is a library module and a library package. It's intended for other developers to actually import this code into their applications. It's not a standalone, main package. So let's take a look at the file structure. At the very root of the repository, we have the go.mod file. Now, this is that kind of simple standard setup where one Git repository happens to have one Go module or one sort of releasable unit of code. And if we take a peek inside, we can see that the go.mod file specifies the import path, github.com/wagslane/go-rabbitmq. So this matches the URL of the Git repository hosted on GitHub. Now, here's the interesting thing. This module only has one package that's exported to the outside world. And it exists here at this top level. So you can see all of these Go files, consume.go, consumeroptions.go, they exist at the top level of the repository. So when you import this package to use it, you just import from this root path because the root package is what you're importing. There are no sub packages to import here. But let's pretend for a second that we did want to export another package in the same Go module. So we have our top level Go module, Go RabbitMQ, and the top level package that can be accessed at the same import path as the module. Let's say we added another directory. We could call it maybe networks, and inside it would be the networks package. If someone wanted to import that package, then they would take the import path for the entire module, github.com/wagslane/go RabbitMQ, which points to the root package, like we already talked about, and they would just append another /networks onto the end, right? So the module path serves as a prefix for any nested packages.
Okay. I think it kind of makes sense. I don't know. I can't really test myself on this, but we're throwing code in package without much thought. I draw a line in the sand and start putting code in different directories. High internals. If you're familiar with pillars of OOP, this is a practice. In encapsulation. Often an application will have a complex logic that requires a lot of code. In every case, the logic that the application cares about can be exposed via an API. Classify image. We can create an API by exposing the functions that the application needs to know about. All other logic is unexported to keep a clean separation of concern. The application doesn't need to know how to classify image, just the result of the classification. API is one. The unexported function within a package can and should change often for testing, refactoring, and bug fixes. A well-designed library will have a stable API so that the users don't get breaking changes each time they update the package version. In Go, this means not changing export function signatures. Don't export functions from main package. In a main package isn't layer, there's no need to export functions from it. Okay. Packages should know about dependence. Perhaps one of the most important and most broken rules is that a package shouldn't know anything about its dependence. As a package should never have specific knowledge about a particular object that uses it. Okay. No. When should you not export a function for a time? Yeah, you don't need to know about it. Should you often change a packet export? No, try to keep the... Yeah. Alright, concurrency, let's go. What's the goal with concurrency? Maybe try to finish it all? We'll see how fast I can do it today. Go.
Concurrency, parallelism, multi...
Hold on, I gotta... Is it... Let's cd learn, go. Okay, let's watch this.
Threaded. These terms are kind of thrown around all of the time in programming, but I want to break down exactly what concurrency is and how it can make your applications much, much faster. And we'll do that from the perspective of the Go programming language. It's also important to understand when concurrency is not effective and won't make your programs faster. Let's jump into it. I want to talk about the difference between concurrent or parallel programming and synchronous or sequential programming. Now, it's worth pointing out at this point that concurrency and parallelism are different, and we'll talk about their differences in a future course. For now, we're going to kind of treat them as the same idea, and I'll just kind of refer to them as concurrency. Similarly, sequential programming and synchronous, they're slightly different terms, but I'm going to kind of bucket them for the purpose of this discussion. We'll be really comparing concurrent code to synchronous or sequential code. So let's start with the easy one. Let's talk about synchronous or sequential programming. Say we have some code, x : = 5, x++, and then maybe fmt.print line x. The nice thing about this code, and what makes it synchronous or sequential, is that the code executes in order from top to bottom, right? First, we create a variable named x, set equal to 5, then we increment it by 1, and then we print x, right? Everything's happening in order from top to bottom, one thing at a time. Now, this is usually what you want. It's simple, it's easy to reason about, it's easy to write code this way. The problem is sometimes it's not the most efficient way to write performant code or code that can run as fast as possible on a given set of hardware. So in order to understand how we can maybe optimize this, we need to look into how your computer's CPU or central processing unit works. So your CPU has a clock speed, which basically, like from a very high level, means how many instructions it can do per, let's say, second. Those aren't necessarily the units, but it is basically how many computations it can do per amount of time. We could just say it's seconds to keep things simple. Okay, so when we're analyzing this code over here on the right, basically what needs to happen is first we set x equal to 5, and that takes up one instruction, right? After that, we get to increment x by 6. That'll take up another instruction, and then we get to print x. So the speed at which we can execute this little program here is dependent on how fast the CPU's clock speed is. So if we want our program to go faster, we can basically do one of two things. Either we can reduce the number of instructions required for our program to execute, or we can get a faster CPU, one that can do more instructions per second. The problem is getting a faster CPU sometimes is really, really expensive. And so instead of getting a faster CPU, what we've kind of done over the years is instead add more CPUs. And in this case, we've kind of broken the CPU up, actually, into what we call different cores. So you might actually have a quad core processor, each of which, let's say, does, 5,000 instructions per nanosecond. I'm totally making these units up, but you get the idea. Any one of these CPU cores can only do 5,000, but the interesting thing is they can all do 5,000 per nanosecond at the same time. So if we distribute our program across all of the cores, in theory, we should be able to go about 4 times as fast. Again, if we use all 4 cores instead of just one. The problem is that most code we write can't take advantage of all 4 cores. For example, let's look at this code over here. We set x equal to 5, and then we increment it, and then we print it. It has to happen in 1, 2, 3, right? In order 1, 2, 3. We can't do all of these instructions at the same time. If we did, then x++ would have nothing to increment because we never would have set an x variable equal to 5 in the first place, and print line x would have nothing to print because x hasn't been set yet. So writing concurrent or parallel code can drastically speed up the performance of our programs because we're able to distribute kind of all the instructions that we need to compute across multiple cores. The problem is we do actually need to write our code in a different way. We need to expect that some of the instructions are going to happen at the same time. And that's what's going to speed up our program. So let's say we had a little bit more code in our program here. Maybe we have y colon equals 6, y minus minus, fmt dot print line y. Okay, this code here in this block kind of dependent on each other, right? We have to do it in 1, 2, 3 order. And the same goes for this block here. But we don't have to necessarily do this block of code where we calculate and print x before or after we calculate and print y. They're kind of separate in that way. So what we can actually do is take this block of code and execute it in one core, and at the same time execute this other block of code in another core, doing them at the same time. So let's sort of visualize the runtime of this program here. If we run this code synchronously or sequentially, right, not taking advantage of 2 CPU cores, but instead doing it all on one core, then our running time might look something like this. I don't know, let's just say 6 nanoseconds. But instead, if we run it across 2 cores in parallel, each core executes at the same time, and they'll each take approximately, let's say, 3 nanoseconds. So we're done in half the time. Again, because we took advantage of the hardware that was available to us. So to wrap up, writing concurrent code in many cases can drastically reduce kind of how long it takes to run our programs. And it depends just a little bit on kind of fundamentally what we are trying to do. So in this case, we literally could take a program and chop its runtime in half by utilizing a little bit more hardware.
Utilizing more hardware. Okay. So what? Go run. Concurrency is the ability to perform multiple tasks at the same time. Typically, our code is executed one line at a time, one after the other. This is called sequential execution or synchronous execution. If the computer we're running our code has multiple cores, we can even execute multiple tasks at the same time. If we're running on a single core executes at almost the same time by switching between tasks very quickly. If we're running a single core executes code almost the same time by switching tasks very quickly. Either way, the code will write and go. How does concurrency work? Go was designed to be concurrent, which is a trait fairly unique to Go. It excels at performing many tasks simultaneously, even using a simple syntax. There isn't a popular primary in existence where spawning concurrent execution is elegant, at least in my opinion. Concurrency is simple as doing go. Oh wow. Will be executed concurrently with the rest of the code in the function. Edit the send email. So that the receive prints after the send. after this. So print this. After receive prints after the send. Okay, let's try that. Wait, what's the difference? Oh, okay, I see. So maybe I say go here. So that received message prints after sent message. After, so send, then this. So this will run simultaneously with this. So it's faster. Okay. Channels are typed thread safe queue. Channels allow different Go routines to communicate with each other. Create a channel. Maps and slices. Channels must be created before use. They use the same make keyword. Okay, make chan. Send data to a channel. Oh snap. Send data to it. A arrow key is called the channel operator, data flow, and the direction of the arrow. The operation will block until another until a Go routine is ready to receive the value. This receives and this reads and will block until there is a value in the chance period. Blocking and deadlocks. A deadlock is when a group of Go routines are blocking, so none of them can continue. This is common bug with units from the current program. Run the program. You see that this is something I've never learned ever. This is the new feature of Go that I'm very excited to explore. Main test.go. So let's oh shoot. Hold on, messed up. It's like an infinite while loop. Yep. Let's see, a group of wait. Hold on. it's nice. I just kind of figured out a new keybind. The prefix, and then you press A again, it goes back and forth, which is kind of useful. So we make a channel, we call a function send is old, which is going through the email array and checks if it's some time before a specific time. If it is, then we set the current channels to a different boolean to true. So all of them are gonna be doing this at the same exact time, which would block it. The send old fudge is trying to send the channel, but no go routines are. Oh, so you have to say go. Fix it by spotting go routine to send is old values. Is old values. So you say go like this. Is that how this works? This has to be a function call though. Or can I say this? Wait, hold on. Whoops. Can we say go? Interesting. So if we say go here, then it's just gonna run oh, I see. It's gonna run sequentially, and then it's gonna run one at a time and blocking it or something like that. This operation will block until there's a value in the channel to be read. So yeah, it started the chain of that, and these won't let, and it will be stuck forever. This operation will block until go routine is ready to receive the value. Oh, I see. Damn, this is very messes with my brains. Empty structs. Oops. Oops. Okay. Are often used as unary values. It's an operation with only one operand. We don't care what's passed through the channel. We care when and if it is passed. We can block and wait something is set on a channel using the following syntax. This will block until it pops a single item off the channel. Then continue. This will. Then continue discarding the item. So our Mailio server isn't able to boot up until it receives a signal that its databases are online, and it learns about them being online by waiting for a token on a channel. Run the code, it never exits. Okay. I think it's gonna start crying. Oh wow. The channel passed to wait for DBs. Where is that used? Where is wait for DBs? Pass to wait DB stays blocked. Huh? fix the wait for DBs function. It pauses execution until it receives a token for every database from the DB channel. For each time wait for DBs reach a token. Wait, so fix the wait DBs function. It should pause execution every time it receives a token for every database in the DB channel. Oh, I see. Why don't you just call the function instead? Wait, so why can't I call wait for DBs num DBs DB change here. Testing database 1. She's taking a while. I don't think I did it right. I still don't get what is happening here. Like, you're passing data to a channel. It's like a queue or something. Damn, this is a very interesting, kind of hard topic here. Alright, did it do something? Yeah, my thing is done forever. Maybe, hold on. Yeah, it didn't work. Wait, I don't get what is this. Fix the wait. Oh, I have to fix the function. Okay. So it pauses. It should pause execution until it receives a token for. Wait, so what do I. How do I know it's good to go? Okay, wait, so. Is this what we want? Struct. Is that what we want? I kind of don't get what this is really asking. Yeah, it doesn't work. I don't know what this is asking. It receives a signal by waiting for tokens empty structs on a channel. How do you move on to the next one? Run the code. It never exits. The channel pass to wait for a stage block because it's only popping the first value of the channel. Fix the wait for DBs function. The get This is confusing. I don't know what's going on here. So we get past a testing an array of test cases. DB-chan. Okay. Wait for DBs. Test that. We're supposed to use it somehow. I don't get what it's trying to tell us to use. I don't really care what. Like, I don't care what. This is so frustrating. I don't understand what I'm doing. Being online by waiting for tokens. Empty struct on a channel. Run the code. It never exits. The channel past the wait for DB stays blocked because it's only popping the first value of the channel. Fix the wait for DB's function. It should pause execution until it receives a token for. What am I supposed to do? I don't get what I'm supposed to do. This is so confusing. Kind of a bad lesson here. Oh, receive data. Oh, okay. So if I can receive data by assigning. What is it just saying? Num DBs. I don't get what is happening. DB chain. This is what they want. Num D. What? Okay, I just had this. It's a struct. Wait, what am I supposed to do? Am I supposed to read it? We can block and wait until something is sent on a channel using the following syntax. What is CH? Sometimes we don't care what's being passed through a channel. When and if it is passed, we can block and wait until something is sent on a channel using the following syntax. Okay. This will block until it pops a single item off the channel, then continue discarding them. Oh, so don't do that? Is that what it says? Because it's just blocking it? I don't know. We just don't do anything? I don't know what it wants me to do. Okay. Okay, wait, hold on. Maybe for... And then, do you want me to do that long or something? I don't... Oh. Okay. So it's red, and then do it again. Red again, red again, red again. Right, so does it pass? Is that how you do it? I don't. So this will pop a single item off the channel. Okay, that's doing it once. I need to do a number of that times. Okay. That was kind of confusing. Next one. So would this be, I don't know if it's, no, I doubt it. It's probably just used normal slices. But I was curious on if they use like the queue or something. Optionally be buffered, creating a channel with a buffer. You can provide a buffer length as a second object to make to create a buffered channel. A buffer allows the channel to hold a fixed number of values before sending blocks. This means sending a buffer channel only blocks when the buffer is full, and receiving blocks only when the buffer is empty. We want to be able to send emails in batches. A writing go routine will write an entire batch of emails to a buffer channel, and later, once the channel is full, a reading go routine will send all the messages from the channel and then send them out to our clients. Complete the add emails to queue function. It should create a buffer channel with a buff large enough to store all the emails it's given. Okay, let's make a channel. This is the make of type chan and strings. String, and we'll do the length of emails. We'll take all of the stuff in the emails and do that, you know. And then what do? We made a buffer channel, and then do we just return that buffer channel? Okay. Okay, I gotta do something with it. It should create a buffer channel with a large enough amount to store all the emails it's given. It then should write the emails to that channel in that order. Okay. And do I just channel like this? Wow. Or so for length of like this, return that? Can I return like this? bad type. You should create a buffer channel with a buffer large enough to store all the emails it's given. It then should write the emails to the channel in order. Fine. Oh, I have to write it into the thing. Oh, how do I add it? So I do like chat. Oh, so I go like, I see. So for every emails a channel, send it to the channel, the email, and then return the channel. Awesome. So ICCB, it's like a, if I can just visualize this as a queue, that would be very, very nice. Yeah, just think of it as a queue. Closing channels in Go. I'm sure there's very important. Count reports can be explicitly closed by sender. Do some stuff, then close it. Checking if a channel is closed. Similar to the OK. Don't send on a closed channel. Sending on a closed channel will cause a panic. A panic on the main Go routine will cause the entire program to crash, and any panic in any other Go routine will cause that Go routine to crash. Closing isn't necessary. There's nothing wrong with. Okay, that's good. They still will be garbage collected if they're unused. You should close channels to indicate explicitly to a receiver that nothing else is going to come across. At Mel, we're about keeping track of what our systems are up to date with great logging and telemetry. The send reports function sends out a batch of reports to our clients and reports back to how many sent across emails or send reports sends out a batch of reports to our client and report back how many were sent across the channel. It closes the channel when it's done. Okay, so it takes the channel as in a parameter. It sends it to that channel, and after we're done with the reports, close it. Use the count report function. It should use an infinite for loop to check okay, then so let's check like okay. Let's do for true, I guess. I don't need the value, so I just say okay. Access a num sent channel. If not okay, break, right? Or should we just, we'll return, I'll return later. Otherwise, or actually not break, I can just like return early. Count, let's call it CNT 3, and we say CNT plus plus. Oh wait, CNT plus plus. Turn CNT Boom, return CNT. I think that's redundant. We could just break out. So yeah, break out. How does that work? Damn. Oh, I only got 3. Right? So I pull the data. If it's Boolean, it's false. I mean, if it's closed, then we're cooked. There's no more numbers. If the channel is closed, break out of the thing. Just keep a running total of the number of reports sent. Okay, then should I do, instead of CNT, it's not that, it's taking the actual value. So num reports, running total, so CNT plus equals num reports. Okay, very nice. Range. Concurrent Fibonacci. All right. Similar to slices and maps, channels can be ranged over. This example will receive values over the channel, blocking at each iteration if nothing new is there, and will exit only when the channel is closed. The Fibonacci sequence is Malio's interview problem of choice. We've been tasked with building a small toy program we can use in the interview. Complete the concurrent Fibonacci. So it's that time and again. Yeah. Okay, so complete the current Fibonacci. Should create a new channel of ints. Call Fibonacci concurrently. Okay. Use a range to read from the channel and append the values to a slice. Okay, so result. I think it's int. Use a range loop to read through from the channel and append the values to a slice. Okay, so let's create channel. Make chan int, and then call Fibonacci concurrently. To create a new channel of integers, call Fibonacci. Where do I start from though? I start here and I pass it at n. Okay, I start here and then pass it through. Okay, so call Fibonacci concurrently. So go Fibonacci and the channel I created. Fibonacci. Return result. And then this is going to be putting into the channel. Then for every item, or for every value from the channel. Oops. Is V a value? Okay, so can I just result equal append result V? Expect. Oh, I gotta range it. Range. Range. And return the result. Awesome. So I'm getting the hang of the channels. Sometimes we have a single Go routine listening to multiple channels and want to process data in the order it comes to each channel. Wait, hold 1 second. Alright, select. I see. I've seen select before. A very asynchronous programming. Sometimes we have a single Go routine listening to multiple channels and want to process data in order it comes through each channel. It is used to listen to multiple channels at the same time. It is similar to switch statements, but for channels. The first channel with a value ready to be received will fire its body, will execute. It will choose, it will time and choose. The OK variable is the example above, refers to whether or not the channel has been closed yet by December. Complete the log messages function using infinite for loop, and to log the emails as they come in order across the two channels. Okay, so these are two channels. Okay, yeah. Implied by the parameter thing. I kind of hate this syntax. It's not very clear sometimes. But yeah. As they come in order of the two channels, so I gotta do a for true select case. Okay, case email. So let's say E for email. Okay. To toss the channel through of the channel emails. A log email of the email. Let's just do this. Case SMS, if it's okay. Change channel SMS log SMS, the SMS. What if I don't need to use okay? Hopefully it doesn't like cry here. Because all I care about is the value, right? And so do I even need this? Go run main.go. Oh! It's infinite. Should I... and a condition to return from the one. Whichever's first. Oh, okay. I guess, hold on, I do need these okays. Okay, so hold on, maybe like, if... Is okay in the scope? I don't think so. If okay, not okay, turn out. Who knows if this could have been one of those, you know? I don't know if I did this right. Is there like a default? Okay, kind of nice. I don't know if I did it right. Right. Is there a better way to do this? I don't know. I can't think. Select default case. Oh yes, this is perfect. This is exactly what I was saying. Default case. Okay, so the default case in select statements executes immediately if no other channel has a value ready. Case stops the select statement looking from blocking. Okay. Save backups. Time.tick is a standard library from that returns a channel that sends a value on a given interval. Time.after sends a value once after the duration has passed. Time.sleep blocks the current go routine for the specified duration of the time. The function takes the time.duration as an argument. A channel can be marked as read only by casting a channel to a chan type. Look at all good backend entries. We frequently see backup snapshots of the Mailio database. Complete the backups function. It should read values from the snapshot ticker and save after channel simultaneously and continuously. It should read values from the snapshot ticker and save channels simultaneously. Okay. This is gonna be hard. It should read values from the snapshot ticker and save after simultaneously and continuously. If a value is received from snapshot ticker, call. Okay, so it's like a select. So we'll do a select snapshot ticker. So we have case this. We're pointing here and we say let's look at V for value and OK. Then call the take snap shot. Save after. Save after. Change to save after V and OK. Take snapshot. Take snapshot. And we have to put in the value. Should we put in V? I see. So we have to do snap. You can work. Oops. So what? Oh, the log chain. Log chain. And then default. Wait for data. Wait for data. Log chan time dot sleep 500 times time dot milliseconds. Can I just have this? Like, would this be fine? Because, like, I don't really care what the value is or if it's good or not, you know? Go, okay, go test dash. Can I just go test? Yeah, I don't know why I do dash V. Nothing to do, waiting. Oh lord. Oh lord. Maybe I do need to have these joints here. Man, what am I supposed to do with these? Oh, and return a function. And return. Do I do the same? I don't know. Okay, maybe I don't need any of these. This is some bull crap. Oh, wait. Take snapshot. Why am I doing the same thing? Hold on. So save after. Called save snapshot. And then what do I return? It's just waiting. Do I need an OK? What am I supposed to do with these return values? Nothing? Values received from a snapshot taker. Take snapshot. Do I return the value or something? Well, I'm not returning anything, so the save after. I don't know what's going on. I don't know what I'm doing wrong. Just waiting. Maybe I'm sleeping for too long. Let's see what happens when I do this. For true as well. I doubt it though. It's not really supposed to have it like that. Oh. I was supposed to do for true. Oh, it should read values from continuously. So I always have to, I assume you need some kind of foreverness, like to continuously, this just ran at once. Okay. Awesome. Let's keep going. Let's see, channel reviews. Here's some few, ooh. Let's give this a read actually. Most new Go programmers quickly grasp the idea of a channel as a queue of values and are comfortable with the notion that channel operations may block when full or empty. This post explores four or less common properties of channels. A send to a nil channel blocks forever. A receive from a nil channel blocks. Receive, send, close, panics. A send to a nil channel blocks forever. The first case, which is a little surprising to newcomers, is a send on a nil channel blocks forever. We create a nil channel and we send it dead blocks. This program will deadlock on line 5 because the zero value for an uninitialized channel is nil. A receive from a nil channel receive is also the same thing. So why does this happen? Here's one possible explanation. The size of a channel's buffer is not part of its type declaration. So it must be part of the channel's value. So it must be part of... Oh, it's not part of its type declaration, so it must be part of the channel's value. If the channel is not initialized, then its buffer size will be 0. If the size of the channel above, then the channel is unbuffered. If the channel is unbuffered, then the send block will block until GoRoutine is ready to receive. If the channel is nil, then the sender and receiver have no reference to each other. They're both blocked, waiting on an independent channel will never unblock. A send to a channel panics. The following program will likely panic as the first GoRoutine to reach 10 will close the channel before its sibling. Will likely panic as the first GoRoutines to reach 10 will close the channel. Will close the channel before its siblings have time to finish sending their values. A send to a closed panics. Yeah, I've heard of that. So why isn't there closed that lets you try to... Solutions for dealing with the fan in the problem are discussed. Okay, a receive from a closed channel returns the zero value immediately. The final is the inverse of the previous. When a channel is closed, all values drained from its bow. The channel will return 0 immediately. Down, close. The 4, 0, 1, 2, 3, and then the 0 value. Okay. This is a for range loop. Alright. An undeclared initialize is just like a nil slice. Blocks forever. Okay, what happens when you read blocks forever? You send it panics. Ping pong. Many tech companies play ping pong in the office during the break time. At Melio, we play virtual ping pong using channels. Run the code as is. You should see that it doesn't do anything in your interest. No ping, no pong, or bishop. Okay. So let's try go run main.go. Nothing happened. fix the ping pong function. Ping pong. So we have a ping pong, go, go, for range, pongs, got pong. Shouldn't you also do this as well? Pings. What does ping pongers do? It just sends a message. Okay. If a program exits before its Go routines have completed, probably, I don't know, this. Should I just not have these running? If a program exits before its Go routines have completed, which of the function calls probably shouldn't run in the background as a Go routine? Oh, this. Nice. Last one. Oh, what am I doing? Process message function takes a slice of messages. Okay, it processes each concurrently with the Go routine. Using the process function for it to simulate the benefit of Go routines. Use channels to ensure that all messages are processed and collected correctly. Okay. Okay, so like, let's iterate. So for message, range of messages, call the Go process, the message, I should also create a channel, make chan string, and then channel send this to message, and then hold on. Wait, what am I doing? Do I need to, hold on. Too slow. It should process each message concurrently with a go routine. Okay, I see. Uses process for this to simulate the benefit of go routines. Use a channel to show all messages are processed and collected correctly. So do I just like that and then channel pull the channel, and then what do I do? So if I pull the thing out, use the value, and then store the value, and call a results function, a string, and result equal append the thing. Oh wait, go test. Yeah, it broke. I don't know what I'm doing. I don't get what it's trying to process message. I'm stupid. I don't know what I'm doing. Oh, wow. This is a hard. Why is this a hard? Needs to speed up message processing using concurrency. Implement the process message function. It takes a slice of messages. It should process each message concurrently with within a go routine. So I call go process. But why? I don't know what I'm doing. This is kind of bullcrap right here. This is just weird. I don't know why. What's the purpose of the channel here? Processed and collected. Okay. Okay, so maybe I process the string, right? So go process the message, right? And then what I should, right? Then should I can I assign a value like this? It's not possible. I see then. Okay. What am I supposed to do then? It should process each message concurrently at the same time. Each message. Okay, then a for true. So maybe okay. First, let's add each message to the channel, right? So how do I do that? You point to it, like that. Then, for true. Go process each message. Point the channel, and I'll try that. Okay, broke it. Oh wait, hold on. Wait. Go process. Oh, okay, process it and then I gotta add it. I gotta add this. Go message and then what is it? Process and then what is it? Go process, then put the message. I had to really think about this. It should process each message concurrently within a Go routine. Use process function to do this for this to simulate the benefit. Okay, maybe I'm thinking it. Should I just not use a Go, just process and take that message into the channel? And then for true, result equal append the channel result the channel. So I don't need for. I don't know why he's not doing this. Oh wait, hold on, not for true. For true, if oh wait, this is actually way more convenient. Let's actually peel this apart. So we could say value okay dot equals equals. If it's okay, then add it. If okay. If it's not okay, then break. Otherwise, add it and then return the result. Does this ever close? Oh. Bro, okay, I guess there's nothing that tells me that it's gonna close it, so it's never gonna break this. I guess I can close it here, right? Oh, hold on. So that's why I do go here. I can't think. I don't know how this works. It's so freaking my brain up. It should meshes concurrently with the Go routine. A process function for this similar to benefit of using Go routines. Use a channel to ensure that all messages are processed and collected correctly. Then return slice of processed messages. So I should process it all at the same time. So I add it. So this is what I'm doing. I'm adding it to the thing. No, I'm just adding everything. Right? I'm adding everything. Message to the thing. I'm adding the message to the thing. Then I can kind of unqueue everything, right? Channel, right? Bro, I'm so lost. How am I supposed to... Okay, what am I supposed to do with a Go routine here? Go the routine, okay. So I could say go. Okay, go and call the function. But I can't store the value. Wait, so what do I do when I go? What happens when I... Let me see something. Okay, so FMT import FMT print like what happens when I do go process message? Obviously I can't do that. So it just literally returns nothing. Like how what can I assign this to something? Does the message get altered? Okay. Ugh. Getting so tired. I don't know what I'm doing. Maybe it's the order that I need to put it. So if I can add them all to a thing, but I also right, I can do okay, maybe I can make this a function. Okay, I do this, but I have to read it so that it doesn't block. It won't let me add this one, right? So I have to go process that somehow. Go process the current channel value. But this is not gonna help because this doesn't, I don't know how to capture the result. Right? It's just gonna run. Like, can I, like, append? Like, I can't use this value. Oh, wait. I wish. Yeah, it's not gonna work. Like, there's nothing that, like, I can't use this. Alright, let's really break this down. How to use the values from a Go routine function. Catching returns from Go routines, yeah. Oh, I can't do this? So how should I... To fetch a value from a Go routine is channels. Channels are pipes that are connected to Go current. You can send values into the channel from one Go routine and receive. Okay. Okay. You could easily obtain a value from a Go routine, not breaking current currency. Okay, so I have to go do, okay. I have to go funk, so go do this as I'm putting in the thing. So each message so as I'm coming, so as I iterate through the messages, I want to add them to the queue, process it, and when I exit out, I add okay. So like essentially I want to do this. Essentially, obviously this is wrong, but hold on. Something like this, where I catch the result, right? I'm not using freaking result anymore, or message anymore, so I have to add it at the same time. Channel, okay, so you can send values into channels from one Go routine and receive those values in another Go routine. Oh, okay, maybe I can make a okay, I can make a Go, I can make a, okay, I can do this. So, okay, let's make this, let's do this. Let's make a thing where it processes each thing. Let's do that. Let's just process. Let's do this. So this is gonna be the part where I put in. This is done asynchronously. So go funk. This needs to be done asynchronously, right? And then what do I do? What I do? All I do is just add them to the channel, right? An expression in Go must be an expression in Go. Oh my God, this is really annoying. Must be a function call. Oh. We'll do this. Let's do this. I for index. And we're saying messages I. Add that to there, right? Wait, what? What do you mean? Oh, whoa, hold on. So this is a function, yeah. There you go. So we added to the thing. Do another one of these where it's gonna go back, essentially go back and forth. But instead of adding, I'm reading values. So I could do like this. Like this. I'm reading values. Processing it. Oh, okay, I don't need to. Hold on. I don't need this. Process the value here from the channel, right? And result equal append to the result array the process thing here, and then return the result. It's gotta work. I failed. No, it's too fast. I just got an empty array. Awesome. I'm so close. I know I am. This essentially should be going back and forth here. Oh, maybe I'm doing this wrong. Let's say I put. Hold on. Let's do v. Oh yeah, I gotta be careful, right? I gotta be careful. Value and okay, right? If not okay, return out to be safe. And after this is done, I should just close the channel. And then if obviously I need to process the value, so let's do the v. Dude, what? Okay, I shouldn't return out. I don't. Just, can I break out of a function? Should I just not be safe and just break it? I know this is bad practice. I don't wanna pull if it's closed already, right? If it's not okay, then return. I can guys just return early like this, you know, because you're done, right? It's not in the scope. Oh. Wait, why can't I return this? Okay, it shouldn't return anything. I just return, and then it should just go here. What? I close it. Or it shouldn't just not close automatically, bruh. I swear to God. Okay, I don't care about closing. Just give me the value. Right? I failed again? I'm just getting an empty list. What? So I'm just returning this. I'm not adding. This is not working. Go func. I need to process this. What if I just process the thing? Right? I process it. Right? And I just get the value. And just append the value. Bro, what? I'm really not adding to the array? Am I not making a slice correctly? What am I missing here? Should I not close either? Shouldn't this automatically close as well? I don't know what I'm doing wrong. taking so long for this. This is really difficult. I don't know why. This channel stuff is kind of confusing. So I pull the data. Result goes here. I put the process thing here. And I use it here. And then I'm good. And it will go to the next one. It won't block it. Instead of... that's fine. Oh! What if I do this? Instead of this, what if I just do the for item range channel? I don't even need an asynchronous function. For... maybe I do. I don't know. Item range the channel. Item. So let's do result equal append. I got an infinite. It blocks it because no, you're not reading it. I guess you're not really reading it. You know. What if I do it? What if I do it go synchronously? I have to do it. What if I What if I do it synchronously or asynchronously? It's the same thing. I'm not reading. I'm not adding to the thing, bro. Why can't I add to the list? I'm stuck, bro. I don't know. I don't know. This is really difficult. Like I have to use it somehow. And I guess this doesn't count. Right? So I add the string to the channel and I need to use the channel. It's blocked right now, right? This is blocked. Use it where? Let's add it. Like I can use it like this. But I want to result equal append to itself the value. I don't know why this doesn't work, you know? Okay, I might have to app AI. Stuck as hell here. We'll ask it to not give me the direct answer. Alright, what is wrong with my code? Don't give me the answer directly. You have two coders, one sending messages and one trying to receive them. Is there a guarantee that the second runs? Okay. You're sending multiple messages to the channel, but receiving go routines. But receiving. Maybe instead of this, I should do like a for true, right? For true. And then say messages I, and we say I equals maybe this is not for true, say for I length of messages. I don't know. What am I doing wrong? And I gotta I plus plus. I don't know. It's probably the same thing. Reading for you're sending multiple messages into the channel, but you're receiving go routines only only reads one message. Okay. Shouldn't it take turns? Oh, it just returns. So I gotta wait. Should I do this? No. Does it ever close the channel? The first Go routine sends messages into the channel, but does it ever close the channel? Okay, I guess that matters too. Like, close channel once it's done. I send this. We're gonna wait. We're gonna run this one, right? It's gonna run simultaneously. Oh, what if I do this? Let's do a select. Right? Select. And case v. Honestly, I'm gonna process it. No, it's fine. From the channel. And just result equal append result v. Of course, this is the channel, so we gotta do this. Default, I don't really care about default. And this is a for true. For true. When does it ever stop though? Damn, I there's like no case to end it. I don't know. How would I end this? How do I end this? This is really annoying. You have two routines, one sending messages into the channel and another trying to receive it. Is there a guarantee that the second Go routine runs long enough to receive all the messages before a process message returns? I gotta run it long enough. This is what I need to. I need to make this run longer. Yeah. Could I do this? Like, okay. Channel. And then, while okay. Yeah, why not? Bro. What are you talking about? What is this? For okay. Add it to the list. But it's gonna. Does this rerun? I guess the value is useful. Bro, it's just running too fast. Yeah, I don't know. Can you give a bit more of a nudge? Yeah, it's causing a deadlock. I know that. You loop over instance messages, but does it finish properly? What happens if the receiving goal isn't ready yet? Yeah, function exit too early. Should I do it in the same function instead? Like with this? Result. Well, I can't because I have to. That's so annoying. What if I like result? Channel, but I use the value. Why would this not work? Yeah, it's the same exact thing. It's running and it just returns too early. Okay, how would you do it? What the fuck is this? This is such a terrible fucking... Okay, I had the idea on that. Let's collect all the so for every message in the channel, append result and there's range result and then the message, right? But this, I need to do this correctly. What the? This is such a terrible... No. Okay, does this count as using it? If this counts as using it, then I don't need to do all this. I'll just do this. Right? It will do this, do that, do that, right? Is that how it works? No, just stuck here. Okay, so this causes a deadlock, right? Never close, so the prevent a dead, close the channel. Okay, close the channel. Close the channel. Yeah, it's gonna just, oh. Oh, nice. Oh, bro, I just had to wait a little bit. I swear I had this solution. Oh my god, that took way too long. It's okay. We still got it through. Next lesson, we're gonna do mutexes. This is nice. After mutexes, generics, humans, and we're almost done with the Go course. This is probably my favorite lesson. I struggled a bit, but we still pulled through. But anyways, kind of a long video. Oh wow, 2 hours. Longest video I've done so far. But anyways, thanks for watching. I'll see you for tomorrow's.